So, hello, John. First of all, thank you so much for finding time to record this podcast with me. I'm really excited to interview you for numerous reasons. First of all, because
I really do like podcasts.
oh, really? I'm so happy to hear that. So,
Yeah, this is
yeah,
actually my will be my second podcast appearance. I went on
really.
Station some time ago. Yeah, so it's nice to be back here on a podcast.
I'm glad. I'm really happy to have you. So before like all the juicy questions and before I get to them, can you maybe share a bit about your background and how you really got started with Rust? Because I'm not sure about like other communities that you're active in, but I know that in Rust
Right,
you're a big celebrity.
celebrity. Wow, that's very kind of you. I mean, I'm obviously not that big of a celebrity, but wow, celebrity, nice. Glad to kind of surreal to hear that, isn't it?
Mm-hmm.
Anyhow, a bit about my background. I grew up in not really any kind of engineering family, really.
Mm-hmm.
And mostly everything I've learned about computers is mostly self-taught.
Mm-hmm.
I decided to Google how to make video games when I was 8 years old, as your average 8-year-old does. And before I knew it, I was programming in QBasic.
Mm-hmm.
And that was really a start. I think that was the start of my programming experience, right?
Mm-hmm.
That's when I wrote my first line of code. And of course I started with QBasic, right? QBasic was the first. And then eventually I decided, okay, it's fun, but it's a little bit basic. How about C sharp? And C sharp was like the first language I really programmed in, like really decided to just build a bunch of apps in. That's
Mm-hmm.
where I learned most of what I know about programming today.
Mm-hmm.
And I kind of dabbled in a bunch of other stuff, C, Java, C++,
Mm-hmm.
and I was kind of doing that. And really, my first introduction to Rust, I was working on a project with another person, right? And we were writing it in TypeScript.
Mm-hmm.
It was like a website type thing.
Mm-hmm.
And they're like, "Hey, what if we do this in Rust?"
Mm-hmm.
And of course, I say I've never used this programming language before. I don't know how it works. They encouraged me to learn it. So I decided to pick it up. And at first, as a newcomer whose main experience is C sharp, it's confusing. I don't understand how files work. I don't understand how anything works, for that matter.
Mm-hmm.
But then eventually I start getting grips with it, getting the hang of it. And eventually it gets to the point that, yeah, I'm like, Rust is now my preferred language. I started off with the website project never really made it into production.
Mm-hmm.
I think the other person's still working on it, so good for them. So I ended up deciding to try to write a GUI framework in Rust,
Mm-hmm.
which, okay, a GUI framework is a really hard thing to write because it does. I feel like we'll probably talk more about this later. I'm just kind of talking about how I got started. And yeah, that was like really when I started doing Rust. Like when I stopped doing like other programming languages for fun and just started basically spending all my free time on Rust.
And just
That's
to
how I got
interrupt
started, I'd
you,
say.
what year was this?
Sorry?
What year was this? Like when you
What year
began
was
your.
this? I don't know. I like to. It's a bit inexact. I'd like to say 2019 or 2020.
Mm-hmm.
I was in my last year of high school. It'd have to be.
Mm-hmm. Mm-hmm. Oh, oh
So
my God. So you're
it
younger
was.
than
It was.
me.
Oh, really?
Yeah.
Wow. Yeah. A little
Okay.
surreal.
Yeah, true.
Yeah. It's. Yeah. That's. My last year of high school is when I really got started with like doing Rust. But like COVID is when I started doing it a bit more seriously.
Mm-hmm.
We're talking like first year of college is when I first wrote. Is when I like finished breadx,
Mm-hmm.
which I consider being my first real Rust project.
Mm-hmm. Mm-hmm. Okay. Gotcha. Uh, my my second question is, so you tried out Rust because of your friend, obviously, that you were working on a project with. But except that, what really drew you to Rust programming language? Like what really kept you engaged if you compare it to other languages that you had tried or worked with?
right? I mean, with Rust, it's like it's definitely introduces a lot of new concepts to you, right? Like if you've just programmed in C sharp, as I did before I started with Rust, or just programmed in C, it's like wow. I mean, there's no classes. Wow, there's traits. Wow, it's like there's a borrow checker,
Mm-hmm.
and it's just like this completely new thing, but it requires a complete paradigm shift in thought. But my belief is that like once you've started in that, once you've started that,
Mm-hmm.
that's when it becomes real. That's when it becomes. I'm sorry, I'm trying to figure out the best way of putting this. That the kind of shift in thought patterns that you need to use Rust really helps you see programs in a way that works really well in my head.
Mm-hmm.
Like
Mm-hmm.
I can generally, if I'm reading through a Rust program, I can generally pretty easily visualize how it all comes together in a way that it takes me a little bit longer for something like C or C sharp,
Mm-hmm.
because I can look at it and I can see, okay, these are the objects. Here's how they're moving around.
Mm-hmm.
And it's like you try to take that to C. Well, first off, C doesn't have a borrow checker, so you're bound to shoot yourself in the foot more than once. And even
Mm-hmm.
other languages like C sharp, you know what I'm talking about.
Yeah.
I mean, I was actually writing some C the other day, and it's like, wow, you don't have to worry about leaving your variables uninitialized in Rust, because if you do that, the compiler yells at you.
Mm-hmm.
But here in like other languages, it's like a thing that people do, and it's madness. Just yeah, it's just
Oh.
that I feel like the guardrails that Rust introduces make me a more efficient programmer. It means
Mm-hmm.
that I'm now able to with Rust go forward and do and be more efficient than I normally otherwise would.
Mm-hmm. Mm-hmm. I also
Something that
hear. Yeah, please go ahead.
go on.
Okay. So I hear a lot of people saying that when they work with Rust, they're much more productive and also efficient, like exactly what you're mentioning now. But I also hear like people that have not really written much code with Rust that if you compare writing, let's say, Python versus Rust or even Java versus Rust, with Rust you will have more lines of code. So how can you be more productive if you're writing in the end, let's say, 100 more lines of code, you know? But yeah, the point of Rust is not about amount of code or lines that you write, but rather how easy you work with the language itself and how fast you catch the errors and how much Rust up yells at you during the compilation time, you know?
Completely disregard the lines of code metric here. I do think it's important, especially when it comes to software size and like how much machine code that translates down into, right?
Mm-hmm.
Like I feel like writing lines of code tells you nothing.
Mm-hmm.
Like I mean, Chat GPT can write a million lines of code a second, right?
Mm-hmm.
You still wouldn't trust it to write any kind of significant program. Effective programming, in my humble experience, is mostly about getting the ideas down, getting concepts down in such a way that they can be easily transformed into a computer doing something.
Mm-hmm.
That's actually why I'd say Python is my second favorite language, because Python
Really?
makes it really easy to translate, like, okay, what do I want to do in my head to, okay, what does the computer do,
Mm-hmm.
in a way that's simple, in a way that's easy.
Mm-hmm. Mm-hmm.
Anyways, what I'm trying to say is writing code is only one step of the process, right? Because it's largely it doesn't really matter how fast you write code in the end, right? What really matters is how fast you can write down ideas. Because once
Mm-hmm.
you get to like higher levels of programming, it becomes a lot less about okay, how fast can you write, and more about okay, how strong are your ideas.
Mm-hmm.
And of course, that's where Rust comes in. Rust really helps that. It really helps me get my ideas down in a way that they can be very easily bounds checked, very easily guardrailed into doing what they reasonably should be doing.
Mm-hmm.
One of my favorite, if forgive me for gassing on a little bit longer about this, one of my favorite Rust concepts is just making making invalid behavior unrepresentable. you should be able to make it so the only things your program can do are the things you want to do. And you should be able to prove this, right?
Mm-hmm.
This is why enums, for instance, are so important to me in Rust, because it basically allows you to say, okay, here's the list of states that your program can be in. It cannot be anything else. You cannot move it anywhere else. If you try, the compiler will tell you, no, you're not allowed to do that.
Mm-hmm.
And
Mm-hmm.
that is just, I think it's just so powerful. Just preemptively deny a whole class of bugs that come from invalid state.
Mm-hmm.
I know it's not a Rust specific thing, or even an idea that Rust really enforces, but I just find it to be such a, and I know this is probably the wrong word for this, liberating philosophy.
Mm-hmm. Wow, that's a strong expression. But is there perhaps something that you dislike about working with Rust?
It's something I dislike about working with Rust. The first thing I'd probably lean towards, I know this is the thing a lot of people lean towards, the macro system.
Really? Oh my God.
Especially procedural macros. Like macros, okay, are very useful. Macros allow us to get down code in such a repeatable way.
Mm-hmm.
But like, there's sort of two ways of doing macros in Rust. There's macros by example, which is macro rules and all that.
Mm-hmm.
I think people kind of just have Stockholm syndrome for that, because like it's just the thing that goes along with Rust, because it is such a frankly just terrible system.
Mm-hmm.
That, like, and I know there are efforts to improve it, and those efforts, you know what, those are great, those are awesome. I'm all for those efforts. Please replace this, because it is just such a bad system of like being able to represent code repetitions.
Mm-hmm.
That I think it's like it's an entire, it's not even Rust like, it's a completely different language.
Mm-hmm. Mm-hmm.
That kind of brings us to number two, procedural macros. It's like, okay, you want me to compile some random code from God knows where and run it on my computer just so you can take in some tokens and output them?
Mm-hmm.
Like, even just ignoring the security implications there, which honestly I think are overblown but are still worth mentioning. It's just not a very efficient system. You're writing Rust and you're compiling a whole nother Rust program just to take in some tokens and put out some new tokens.
Mm-hmm.
I wish Rust had a stronger and more well integrated quasi quoting system like Lisp has. I think that'd be like the best. Like, imagine if you had like, and I think this is actually what they're working on too. Imagine if you just had like, instead of doing like pub fn my macro,
Mm-hmm.
you do pub macro my macro, and you get like a list of tokens, and you just write simple Rust code in line in whatever crate you're writing to automatically transform these tokens into whatever tokens you want.
Mm-hmm.
That would be, I think that's the dream macro system, because that's basically what Lisp has. And don't quote me on this because I'm not involved in Rust compiler development, but I think that's what they're actually working on right now.
Okay, wow. I'm not very familiar with Lisp, but what you explained, it sounds much more efficient than what we currently have.
I mean, it's not necessarily more efficient, just more in line with the Rust philosophy.
Mm-hmm.
And also, I'll add this too. I feel like every programmer should at least try Lisp. Like, it's just such a weird language. It doesn't really have anything else like it out there. I think you should at least try it, just
Mm-hmm.
to expand your worldview a little bit.
Mm-hmm. Mm-hmm. Okay.
Because it just has so many weird properties. Like, did you know you can write a Lisp interpreter that can interpret all of the original Lisp that was invented in the 50s in about like 50 lines of Lisp?
Wow. No, I don't know why I never. You're the first person that even mentions Lisp to me, to be honest. But yeah,
Yeah.
I'll check it out for sure.
I mean,
Um,
and I will definitely extol the virtues of Rust in this interview. I'm sorry, I'm stretching out question number two quite a bit here.
no,
But
no,
like,
it's fine.
especially as Rust programs, you should also be learning about, the even more experimental languages, right?
Mm-hmm.
Because Rust has made leaps and bounds by like being very experimental, being able to take a lot of ideas from a lot of different places and combine them in a very systems level way.
Mm-hmm.
But there are other languages like I mentioned Lisp, and also Haskell, and also Scheme. Oh, that's another type of Lisp, but still, that take all this and push it to what's probably the limit.
Mm-hmm. Actually, I have tried Haskell before, and we also had the course in university, and I really enjoyed the language, to be honest. Um, yeah, it was an interesting one because I had to think a little bit different to what I was used to, coming from Java slash C++ slash C
I put up like a
courses.
light here. I mean,
And oh, have you tried Zig?
Zig, I haven't tried yet. I've had a lot of people recommend it to me, right?
Mm-hmm.
Just because, like, I hear a lot of good things. The integrated C compiler seems pretty nice, and especially the commitment to like being able to compile to another platform.
Mm-hmm.
I mean, I like that about Go. I don't really like Go that much, but I like that about Go. Just being able to just compile from any platform to any other platform without any hassle.
Mm-hmm. Mm-hmm.
It's something I've been meaning to try out, but like I'm pretty busy nowadays, so I haven't gotten the opportunity yet.
Mm-hmm. Of course. Um, let's see. Oh, okay. This is my third question. How has your journey been from a beginner in Rust to an active contributor in the community?
Yeah, well, certainly it's been a journey, and I'm gonna kind of explain it. So I sort of mentioned earlier, I was as a Rust, and I hate this word newbie. I was trying to start off with a GUI framework, right?
Mm-hmm.
And of course, I realized that's really hard because there's a lot of different GUI interfaces, right?
Mm-hmm.
For Linux, you have X11 and Wayland.
Mm-hmm.
For Apple, you have AppKit, and there's also like the new thing. What's it called? Swift UI.
Yeah, yeah, Swift UI.
Yeah. Windows has the whole Win32 plus. I mean, whatever framework Microsoft is pushing now, I don't even remember.
Yeah, I'm not aware either.
And don't even get me started on like iOS and Android.
Mm-hmm.
So like, there's a lot of things to do. So I figured, okay, what I'm going to do here, and this is after like about a few months of trying and failing, I'm just going to focus on X11 because that
Mm-hmm.
seems pretty simple. That's a lie, by the way. That seems pretty easy to implement for me, for someone like me. I'm just going to implement X11 here. So I start creating BreadX, which is really the first real Rust project I did. It involved a lot of things. I had to learn about how networking protocols worked in Rust. I had to learn about okay, how do you automatically generate a large amount of code in
Mm-hmm.
Rust using Rust? And in the end, I did get there. I created an implementation of X11. Now I was able to use it successfully, like open up windows and like draw stuff to the screen.
Mm-hmm.
And it was great. It was impressive. I loved it.
Mm-hmm.
So I guess if you're taking notes here, and really this is a good idea strategy for any like new thing, just like try creating a project in it, right?
Mm-hmm.
It's how I learn it. It's my favorite way of learning something. Just like try to create like a new project. I'm gonna turn down this light. It's actually like shining into my eyes here. And really creating a project like that is probably the best way of just doing it. You really, the best thing you can do for yourself if you're trying to learn something new is just. I
Hands
think this
on.
is manageable now. Yeah, I just turned it down a little bit because I felt like it was shining right into my eyes.
No problem.
The light in this room isn't really that good. I apologize for that.
No, no problem.
And that's really where I started. That was the origin point there for me, BreadX.
Mm-hmm.
And I basically stopped maintaining BreadX. There was a competing library, X11RB. We shared a lot of code at first. Now I mostly contribute to X11RB. I'm going to be contributing to X11 because I like its design philosophy a little bit better.
Mm-hmm. Gotcha. Um,
Anyhow, that's where I started, and I guess active contributor. So while I was writing BreadX, one of my goals was to make it asynchronous, right?
mm-hmm.
Because you have this whole async await thing, and I realized pretty early on, okay, this is powerful because it lets you do multiple things at once, and I want to be able to integrate it. And I see Tokayo, which is like it still is the main async library.
Mm-hmm.
It's big, it's complicated. You can understand it, but it takes like a solid week of digging through source code. It's got a lot of unsafe, and it's all just this one big blob, right?
Mm-hmm.
I don't want to put any shade on Tokayo. I do not want to be misconstrued. It's just not my flavor. Then you have smol, on the other hand, which
Mm-hmm.
is just it's like a breath of fresh air for me. Because I'm walking in, it's like, wow, I can just plug whatever I want into the runtime and it just works,
Mm-hmm.
which was incredible to me. Because that meant I could just take an X11 connection, which is a socket, but it's like a socket wrapped by a C library,
Mm-hmm.
and I can just register that into the runtime like it's any other kind of socket, and it just works. Just no big deal, it just works. So of course I start reading through the source code, and I realized this is just some ridiculously good source code. It was written by
Source code of which one?
smol,
Small. Okay, yeah, gotcha.
smol, specifically the async IO crate,
Mm-hmm.
because it was mostly written by someone who has they've now distanced themselves from the Rust community, so I'll avoid calling them by name here.
Mm-hmm.
But it was written in just such a wonderful way because you read it and it's like you can get the impression that this source code wasn't just created to create a product, right? It was created to be read like a
Mm-hmm.
book.
Mm-hmm.
Like I was reading through it, and all of a sudden everything just becomes so clear to me. Like I can see now, okay, that's why they do this. That's why they plug this into the reactor. That's why this map is there. That's why all these sleeps are here. And it's just like incredible to me because it's like, wow, I completely understand this. And of course, I see a few areas of improvement. So I open a couple of PRs.
Mm-hmm.
I mostly still work on BreadX. I see a few more areas of improvement. I open a few more PRs. I keep doing that for a couple of years. Then before I know it, I get an invite to be a maintainer of smol.
Wow.
So that's kind of how I got from humble beginnings to being like writing a lot of PRs.
Mm-hmm.
That's how that happened.
And what about the community itself? Um, so you obviously you interact with community a lot.
Right? Yeah.
Mostly through I don't know, you also have a blog and you also have to interact people
Yeah.
opening PRs.
Yeah.
Um, what
That's
is
just
your
part of how Git works.
what is your take? No problem. What is your take on the Rust community?
Community is pretty good, I'd say.
Mm,
I'm not going to say it's great. There have been a couple of incidents that I think I have to bring them up here. Like the David Tolnay incident, that was not good. Like
mm-hmm.
the fact that it was allowed to get to that point, let alone like continue way past that,
Mm-hmm.
is just shameful. Not to mention, there's a couple other incidents come to mind, like but it escapes me at the moment. But yeah, the David Tolnay incident's the biggest one. There's definitely room for improvement. There's definitely some drama, but overall, I found it very welcoming.
Yeah.
I found it to be a group of people who are just genuinely interested in collaborating with each other and they getting to the point where they can just write code together.
Yeah, yeah, exactly.
I've interacted with it less the past while, mostly because I have a full time job these days.
Mm-hmm.
But it's honestly a great community. Everyone's nice. Everyone's pretty fun. It's great. I enjoy contributing to Rust, and I guess that's the best part.
Mm-hmm. Yeah, it always feels rewarding to do what you like. At the end of the day, that's what matters the most too. So we mentioned
Exactly.
smol-rs, right? So and you also mentioned that you were invited as a project maintainer. Oh my god. Can you tell us a little bit about the project and your current role in it?
Okay. Good. So I effectively advertise smol as sort of an alternative asynchronous runtime, right?
Mm-hmm.
Basically, just here's a bunch of building blocks for your async programs. It's not all bundled into one thing. It's not scattershot everywhere. Feel free to use it. Feel free to bundle it into whatever you need
Mm-hmm.
and go ahead, use it. The
Mm-hmm.
source code is extremely readable. I feel like your average smol crate, you can read through it and understand the entire code base in about a day.
Okay,
So can we compare that to something like
I want to interrupt you here. So you remember I opened a couple PRs and you were the one reviewing them.
X?
And John, I don't know if you're
Mm-hmm.
aware about this, but actually I'm not a developer at all. I am a DevOps, and writing code
Right.
is a hobby of mine. So even for me, someone that doesn't code for like daily, reading the source code was extremely easy. So I totally agree with you on that.
Yeah. It is great source code, right? I've tried to touch it as little as possible, except for the parts that required pretty big overhauls.
Mm-hmm.
But yeah, it's great source code. You can read through, you can understand pretty much any module in just about a day.
Mm-hmm.
Compare that to like Tokayo, or where you need to pretty much read through the entire thing in one sitting to be able to understand it, and that'll take you like a week.
Mm-hmm.
Not to mention, Small has much less unsafe code. There are a few modules that are pretty unsafe, like async task,
Mm-hmm.
but all the rest are mostly pretty easily understandable in a very short amount of time.
Mm-hmm.
I guess that's the big pitch. It's also pretty fast. I'm not going to call it as fast as Tokayo because the benchmarks disagree with me there,
Mm-hmm.
but I think in certain cases it is faster.
Mm-hmm.
I guess my role, I'm sort of like, I'm the main maintainer at this point. I'm not the only one in the pilot seat. There's also Xenix, there's also Elaine, and
Mm-hmm.
they are all invaluable contributors to Small as well. But I'm main maintainer when something needs doing. I'm usually the one who does it.
Mm-hmm.
I review stuff. I fix bugs. I'm the one who publishes stuff nowadays. Previously, it was another fellow. I'm not going to say their name. I think they intentionally shy away from publicity.
Mm-hmm.
They're also the maintainer of a few other well-known Rust crates like Futures. It was mostly them. It was pretty low volume, so I feel good because I feel like I'm able to effectively be a good maintainer of this project here, as well as other. I'm not sure if I mentioned this yet. I'm also the Windows and Linux maintainer for Winit, which is the main Rust windowing library. That's arguably very much higher volume, but I do that too, as well as a couple other crates. And generally my main role, I like to see myself. I'm generally very opinionated about a lot of things, so
Mm-hmm.
bring my opinions to the table. I feel like it does a lot of good because I'm able to influence what happens
Yeah, that's
in such
good.
a way that it creates good code.
Yeah, yeah, that's for
Not to
sure
mention, I
good.
feel like I bring a good eye to reviews. I bring a good pair of hands to the writing code part of the whole thing.
Mm-hmm. Mm-hmm.
My role, I'm the maintainer.
Gotcha. Now tell me like one of the, or maybe some, I'm not sure, biggest challenges that you have faced while working on the library itself.
Okay, I'll tell you, I'll say two stories that come to mind.
Mm-hmm.
So let's start with a hard story, like one of those big heart wrenching stories that makes you feel bad for a while. Uh, so basically, there's Event Listener, right?
Mm-hmm.
It's one of those big unsafe crates that I talked about a while back. It also underpins a lot of small because it does something very simple but also very powerful. It lets you take like a thread
Mm-hmm.
and wake up another task with it. It's sort of just the easy way to wait for something to happen. And underpins our mutex implementation and our channel implementation and a lot of other things.
Mm-hmm.
It was also, in my opinion, pretty poorly written. It had a pretty poor concurrency model. It was basically a mutex around the linked list. I felt like I could do better than that. So I rewrote it to have a much more optimized implementation. Not
Mm-hmm.
only did it also support embedded platforms, it also was very much faster. Like I think in benchmarks, I recorded it being up to twice as fast,
Wow.
largely just by avoiding too many heap allocations. It required a couple breaking changes, but I felt like it was worth it, so I released Event Listener v3.
Mm-hmm.
Then one of the other maintainers they point out, oh yeah, this API has a ton of foot guns in it. I mentioned earlier that one of my favorite parts of Rust is the ability to enforce correctness, right?
Mm-hmm.
And we were very much not enforcing correctness. So we rewrote it a little again, lost in performance, and released Event Listener 4.
Mm-hmm.
And someone points out, yeah, there's a pretty big bug with this API where you can use safe code to create a null pointer dereference.
Mm-hmm.
So I had to throw that all away, rewrite it, try and make it as simple as possible. Bada bing, bada boom. Event Listener 5. Right, a little bit. The current implementation has a couple flaws. I'd like to make it more simple and neat, readable, and also fix some of the concurrency issues that I've seen in practice.
Mm-hmm.
I think it works well in most cases. I don't get many bug reports in there,
Fifth time is the charm.
but yeah, but it's not the kind of library people file bug reports against. It's kind of low level in the stack.
Mm-hmm.
So I feel like I feel bad about that because I'm pretty sure that might be used in some place where it could be causing a lot of damage. I
Mm-hmm.
wouldn't even know it. But I feel like currently it's pretty good. It supports no STD. It does a lot of things very well.
Mm-hmm.
And I'm pretty happy for the most part with how it's turned out.
Mm-hmm.
That's the rough story. Now for the feel good story. Up until now, I've given you the impression that smol is a Rust library.
Mm-hmm.
And it is, right now, before I got a hold of it. And here's a very scandalous thing I'm about to tell you. It has a C component in it. A part written in C. Ooh. It was the Windows implementation had like some C code in it for polling,
Mm-hmm.
interfacing with the underlying event loop. And basically, it's actually really, really hard to do this right in Windows. Like nowadays, they have better APIs for this. But back in the day, the only API was IO completion ports, which is actually a really good API, right? IO completion ports works really well if you have a lot of stuff going on and you want to coordinate it. It's just really hard to write async code with, just by the nature of things.
Mm-hmm.
It's also kind of a Rust problem, just because, it's just. I'm trying to figure out the best way of explaining this succinctly. In Rust, you don't have to run destructors. In IOCP, you kind of do have to run the structures.
Mm-hmm.
So it doesn't really work out very well. So you kind of have to reach into the bowels of Windows and grab out the secret underlying API it has for all this and use that to pull it directly. And I feel like I did that. I rewrote all that C code in Rust. I made it a lot safer. I created unsafe abstractions, then papered over those with safe code. And in the end, in my opinion, I've created something very elegant here. Very elegantly interfaces with the underlying Windows API.
Mm-hmm. Mm-hmm.
It's
Gotcha.
probably the biggest programming challenge I've faced yet. There will definitely be more to come. You believe me. That's the biggest Rust programming challenge that I've faced so far. IO completion ports in Windows.
And most rewarding one as well. Okay. Okay, so yeah. We are mentioning async programming a lot. And it can be complex. It's quite complex
Yes.
for me. And I'm sure other people struggle with it
Understand?
as
Yeah.
well. How does Rust
Mhm.
handle async compared to other languages you worked with? I mean, let's not really talk about like theoretically or
Yeah.
what's the word? Like just explaining the definition, but rather like
Yeah, let's actually go deep down and compare it.
yeah, I would like to hear your take on it.
Okay, so I've really worked with 3 languages that also have async programming in them.
Mm-hmm.
I think, and that's Python, TypeScript, or JavaScript. I only use TypeScript though,
Mm-hmm.
and C Sharp. And C Sharp, is the one I'm least experienced with. It's it's fine, I guess. It's mostly just a bunch of classes. You create something that inherits the future class, I think, or the future interface, or whatever it's called in C Sharp, and that's a future.
Mm-hmm.
It's fine. It works well enough. A Python, I don't really like the async programming in Python because it feels like the language wants you to use sync,
Mm-hmm.
and it just kind of has async as a compromise. It's really difficult to do async well in Python, I think. That's kind of the same story with JavaScript too. JavaScript and TypeScript, because JavaScript probably does it the best just with promises. Because you just you have a promise object, you pass a couple of callbacks to it. That's a closure. That's it.
Mm-hmm.
It's I found there's a lot of debate about function coloring, but I've always found it very easy to go from async to sync and vice versa in JavaScript.
Mm-hmm. Mm-hmm.
Just you pass it a couple closures. That's your reject. That's your resolve, and that's how you do promises. And I feel like what Rust does, and Rust is, I think it goes without saying, my favorite way of doing async because it has traits.
Yeah.
Now, I think that traits are probably the most powerful feature of Rust. If you want to choose one standout feature of Rust that makes it so different from everything else, from C, it's traits. It's just such a great way of doing advanced functionality because there's no inheritance, there's no classes. You just say, okay, here's my object. It does these things, and that's it. You can turn any object into an iterator or a future or a stream. And it is so just incredible to me that you're able to do this. Like, I think that you kind of said what drew me to the Rust program language earlier. I think I have to add iterators to that.
Mm-hmm.
That's so powerful. Mm-hmm. And Rust and futures makes it so much better. I'm so passionate about it. You're gonna you just uncap me here because with Rust futures, you can take asynchronous computations and chain them together in ways you can't even imagine. Like, you know what iterators do with collections? Rust does with functional programming in a way that I've never seen another language do it. Because it's like in JavaScript, right? Let's say you want to run two futures at a time and add a timeout to one. It's sort of actually kind of tricky to do this in JavaScript. You kind of have to do set timeout. You got to do promise.race, la-di-da-di-da. And it's all like objects, right?
Mm-hmm.
Like every additional layer, in Java, that's like another heap allocation. That's another array. That's another closure, which I forget how that's represented in like V8. But it all adds up. It's all very, and you're going to laugh at this, not zero cost. But in Rust, what you have an object, right? It's just data. Like, if your future, all it does is acts on like an integer. It's the size of an integer. And that is incredible to me because it literally is zero cost. It costs absolutely nothing to do async. What happened? Let's say you want to add a timer to it. Timers in small are 3 words wide last I checked.
Mm-hmm.
You put that in an OR combinator, absolutely no overhead added. It generates a whole new function, a whole new pull function for that future, all directly on top of the OR combinator. It's like if you were to do like future.or timeout, like if you wanted to add a timeout to a future, it costs nothing. It all compiles down to pretty much what would happen if you hand wrote it. And that is just incredible to me. That makes me giddy as a kid in a candy store. That is incredible. And I'm just scratching the surface there. Tower is probably my favorite crate, just because of all the power it adds to async. It pretty much lets you take any async function and say, okay, you want to add load balancing to it? 1 line of code. You want to add a timeout to it? 1 line of code. You want to make it work completely with back pressure? 1 line of code. It is. I mentioned earlier, a lot of people early on complain about, hey, Rust adds like X many lines of code. Like, have you done async programming in JavaScript? Like, the kind of stuff that Tower and Small enables you to do would take like at least 30 lines apiece with JavaScript. Meanwhile, Small, it's like, okay, you want to add a timeout? Okay, that's like maybe 3 extra lines of code, and that's it. It is so fun just to be able to just combine functions like this in such a way that you can build on top of each other. Because I think I mentioned this in one of my blog posts. If you have one way to add a timeout to a future, you can do that with any future.
Mm-hmm.
Like if you write a function that adds a timeout to a future, you can add a timeout to reading a file. You can add a timeout to waiting on network stream. You can add a timeout to your entire program. And that is just it's insane. It's insanity. It is awesome. It is just the best way of doing async. It is so powerful. Being able to combine functions like this is completely zero cost way.
Mm-hmm. And let's say, what about developers that are just getting started into async programming? And I mean, you might be coming from a different language family that doesn't really do async as well. What advice would you give
Be
them?
sharp. Okay. For not read any async books. They are not helpful. They try to throw you in the deep end and it fails. Here's what you do instead. Try to understand it from first principles, right?
Mm-hmm.
Like understand, okay, given something like epoll or given something like IO completion ports, how do I structure a program so that I can handle more than one thing at once?
Mm-hmm.
And then start from there and see how it gets out of scale pretty quickly.
Mm-hmm.
Because with async, without async, it's actually really hard to write concurrent programs.
Mm-hmm. Yeah, for sure, for sure.
Yeah. So start there. Try to see what the motivating use case is, because this is kind of how I understood it later on. And then later on, try to kind of introduce yourself little by little to async. Start seeing how futures add to the experience. And then if you've already had a lot of experience, already have some experience in just creating concurrent programs, async await fits right in.
Mm-hmm.
Like I guess that'd be my advice. Try writing like a networking client or like a server or something using just pull.
Mm-hmm.
Like literally, whoever's listening to this, open up the URL bar, type in docs.rs/rustics, and look up the pull system call, and try to write a web server using that as your only concurrency primitive. No threads, no nothing, just that. And then try introducing async and seeing how much it just makes concurrency better.
Mm-hmm.
I think a lot of stuff tries to make async await just like sync programming, but different. And I strongly dislike it just because why? Async await programming is good precisely because it is so different than what regular sync code does. Rather than trying to make it uniform with sync code, we should try and make it special. We should try and make it even better.
Mm-hmm. I apologize. My cat is acting up, so give me just a
Right,
second.
cat tax, hand it over.
Okay. Okay, and my other cat is
Come
also
on.
my other cat is also making an appearance.
My mom was always allergic to cats, so I never was around cats much as a kid.
Mm-hmm. You missed out on a lot, as you can see.
Yeah, I hear.
So yeah,
I love cats.
yeah, I love them too, and the other one is going a bit crazy right now. So I apologize for that.
No worries. No worries.
So, do you want to add something more, or should I ask you a different
I feel like
question?
I've already said enough flame bait here for this particular part. I just think that for teaching new people Rust, you can't start from the very top level. You can't start with Tokayo. You have to bootstrap it from the base principles. I think that's what's great about Smol, right? Because it very much is. It's very much just building async from the ground up.
Yeah, and also don't read the book. That's also a good advice, to be honest. Because I read the async book myself, and I was left with a lot of questions, to be honest. And I struggled
I've been meaning to write my own async book myself.
Really?
It was actually the project I was doing before I started my current job.
Really? Wow.
Yeah, I haven't finished it yet because it's the kind of thing that like I need to be fired to focus on completely.
Yeah, I gotcha. Okay.
Yeah, it's.
Yeah, you go ahead.
No. You go on. I know we have limited time here.
Okay. Um, let's see. So I think I'll skip on this question for now. Um, what do you think are the most important qualities for someone contributing to open source projects?
Okay, couple things. First, I feel like the best quality is they actually use your product, right?
Yeah.
They can't just be contributing to it for the sake of contributing to it. The best pull requests and the best issue reports I get are from people who have actually tried to use the project
Mm-hmm.
and have naturally encountered errors. So I feel like that's if you're looking to contribute to open source, that's like the first thing you do. Look at what you're currently using.
Mm-hmm.
And if you're not using anything because you're not writing anything, start a project, figure out what you would need to do that project, look at those dependencies and see, okay, how can I improve this? How can this better fit my use case?
Mm-hmm.
That's the best quality, in my opinion, like an actual motivating use case. Because I kind of groan at all the typo fixes and all just the very stylistic things
Mm-hmm.
that come up when programming. A motivating use case trumps pretty much every other quality. Like, I mean, of course, be nice, listen to feedback, be willing to modify your pull request, be willing to take no for an answer, especially from maintainers.
Mm-hmm. Mm-hmm. And
I feel like just the best thing.
yeah.
Go ahead.
No, you go ahead.
The best thing to do if you want to contribute to open source, actually have a motivating use case.
Mm-hmm.
Don't contribute just to contribute. Or if you want to contribute, like start your own project. It's fun. It's fun. But the best thing you can do for open source maintainers, have like an actual driving use case.
Mm-hmm. And so okay, there's that part, and also, I mean, you manage smol-rs, right? You are the maintainer, and you
Yes.
guys have bunch of different
Not the maintainer, a maintainer.
yeah, one of them, and you guys have bunch of different repos, and on
Yes.
different repos, a lot of different people open pull requests. Um,
Yes.
do you like? I mean, it must be challenging to review all of them and also to like manage them. Do you have like some kind of like approach to this, to make like the
I mean,
process of reviewing like more smooth, let's say?
okay, so I guess my approach, I kind of use a very minimalistic approach. Whenever I have free time, which is becoming more and more infrequent nowadays,
Mm-hmm.
I open up GitHub or Codeberg. I have some projects on Codeberg too.
Mm-hmm.
I just look at all the pull requests. I kind of sort them mentally. Can I take this? Do I need to test this? And I sort of work my way up, right? Usually I start with the hardest pull request first. I just kind of eat the frog. And then after that, the other pull requests are usually a lot easier.
Mm-hmm.
I think that's a pretty good strategy because sometimes it's pretty hard because I have to switch between operating systems. Because as I mentioned, I'm both the Windows and Linux maintainer for Smol.
Mm-hmm.
I'm sorry, Winit. That's challenging. Other than that, I also try to follow a good like release cadence because like I can merge a pull request, but it's not released yet. I try every Saturday or so. Just go through all the projects I maintain. If there's new changes on master, publish them.
Mm-hmm. Mm-hmm. Gotcha.
So I think that's what I do. Managing them, I'm definitely doing a poor job of that right now. I just think, last in, first in, first out is a good way of doing it. Just start with whatever is oldest on whatever's on top of your plate, and
Mm-hmm.
then keep going.
Mm-hmm.
And I guess for contributors, first off, remind us to review it because I definitely do forget like to review a pull request if I'm not reminded.
Mm-hmm.
It's like send us a friendly ping. I listen for pings. I take them. A prompt response from your end is also appreciated. And also, probably the best thing you can do to make it easier, try to reduce diff noise. Like, don't do like a bunch of just random stuff, right? Make your pull request very atomic. Make it so I can very easily see, okay, what's being changed here, and why do I care?
I want to comment that the pull requests I've opened, looking back at them, I think they were horrible. and I really
Don't say
appreciate.
that.
Oh, I really appreciate your patience, John. I think you're
Yeah,
really nice, and you always found time to um really, like, you didn't just like give me feedback on what to fix, but you explained like why I have to fix it, and I really
yeah,
appreciate that. And I also told you I'm not a dev, so it was really helpful to
yeah.
me learn better
Yeah,
how.
I do think explaining your process is really important, right?
Yeah.
It's like one of the reasons I really like the original maintainer of Small is because he really had a way of just explaining his philosophy, of explaining why he did a particular thing.
Mm-hmm.
And I've
Mm-hmm.
always found that to be great because, like, when you do eventually write your own projects or when you do eventually need to write your own code, you want to be following best practices, right?
Yeah,
I
obviously.
feel it's definitely what set me ahead of my peers because since I've done so much work in open source, I'm able to just immediately know, okay, if I need to do X with Y tools, what strategy Z do I use?
Mm-hmm.
And that lets me get started and develop much more robust code than other open source devs.
Mm-hmm. Gotcha.
Just that wide ranging experience is very useful, knowing what tools to use.
Yeah, yeah, for sure. Um, so yeah, first of all, thank you for answering, and I think being one of the maintainers must be really difficult. My next question is
It's fun.
about my next question is about your favorite resources, except the async book. Uh, do you have like some books or blogs, or I mean, you also have your own blog. I'll for sure link it
My
in the
blog.
description. For staying
Thank
up
you.
to date with Rust.
Okay, well, I mean, there's a couple things. I mean, the main book, the main Rust book is. I don't even need to explain the Rust book. You know what I'm talking
Yeah.
about, right? That's really useful for just getting started with Rust. That was how I started. That's how a lot of people start.
Mm-hmm.
I think it's very useful. It lays down the explanations.
Mm-hmm.
In terms of forums, I'm actually not in that many Rust discords. Like I'm in a couple, but like I don't pay attention to them. I'm not like actively reading stuff unless someone pings me.
Mm-hmm.
I occasionally go to the. You good?
Yeah, yeah. I think I'm good.
Yeah, cat got in the way.
Yeah.
There's that. Inside Rust, I find to be a pretty neat blog, just because it very much goes into like here's the philosophy, here's why we're doing this in the Rust kernel,
Mm-hmm.
and I think it's very nice. It's a very succinct way of doing it. Faster than Lime and Code Fault, or wait, what's it called? Or fault lore fault, something like that. It's run by the it's run by uh the person who formerly helped develop Homestuck. I'm blanking on their name at the moment. Those two are the main blogs I follow.
Mm-hmm.
It's They have some very interesting insights into Rust. Baby Steps by I'm not going to pronounce his name. Nico is also very nice because it's very insightful into Rust compiler development
Mm-hmm.
and really does tell you, okay, here's why he did that. In terms of corporate blogs, I also follow Ferris Systems.
Mm-hmm.
I do enjoy seeing good posts from them, especially about their Ferricine toolchain.
Mm-hmm.
I think that's very impressive what they did there, being able to create an ASIL 4, or is it ASIL D? I don't remember. Compiled toolchain, basically just off of Rust sources and a couple patches.
Mm-hmm.
I thought that was very, very impressive. Uh, yeah, and honestly, I don't actually follow that much Rust material directly. I prefer to stick close to the source. Like most of my Rust news comes from like notifications I get on GitHub. Like I'm like I say I'm interested in Rust, but like most of the time I'm there at the source. I'm like seeing what's happening firsthand, just by looking at the GitHub threads and looking at like the mailing list directly.
Mm-hmm. Gotcha.
Honestly, I prefer it that way, right? Because it's very direct. I get to see things up close and personal.
Yeah,
And I
happening
get to
in
have
real
an influence
time.
if I really want to. Mhm. Like something I love doing, right? I try to follow every dependency I use on GitHub. That way, if anything changes, I immediately know.
Mm-hmm.
And I love like taking care of like seeing some dependency and they're like doing something I don't like. So I pop in and say, hey, I don't like this. Because you know what? As an open source maintainer, I appreciate that kind of feedback. I really do appreciate when someone says, okay, stop doing X because it doesn't work for us.
Mm-hmm.
Or start doing X because it works for us. And I like to comment on that kind of stuff. I like to be involved in open source development, especially my dependencies. I have become a maintainer of a couple projects just because I like do that, or occasionally write a PR.
My God. Wow.
And so basically, I like getting news close to the source. Speaking of which, LWN, the Linux News Network, that's also a good source of news. I like to keep track of the Linux kernel development. I am awful at OS dev.
Mm-hmm.
I'm probably not going to contribute to the Linux kernel unless I have to. But I do enjoy just following along with it because it is just a fascinating project to me.
Mm-hmm. Uh,
As well as, a couple other dev blogs. I have a Mastodon account. I usually follow various people on that.
what about This Week in Rust?
This Week in Rust is pretty good. I don't usually read it. I have the newsletter, and I'll glaze through it occasionally, but I don't
Mm-hmm.
really follow it that well.
Mm-hmm.
Even back when I had a lot more free time, I never really did. It's fun, don't get me wrong. It's just a pretty big, meaty newsletter, right?
Yeah, for sure.
But yeah. To summarize, I stay up to date with the ecosystem by interfacing my neurons directly into the ecosystem.
Gotcha. And good advice, by the way. My final
Yep.
question to you is, what advice do you have to people that are just getting started with Rust?
Okay. So if you're just getting started with Rust, I guess I have to ask, what do you want to get out of this, right?
Mm-hmm.
If you're just looking for a job, put down the Rust book and pick up a C or Python or Java, because Rust jobs are few and far between. You're probably not going to find a Rust job. If you're looking to genuinely just improve your skills as a programmer and learn a new language, welcome aboard. What you're going to do, read the Rust book, and then just ask yourself, okay, what's a simple project I want to do?
Mm-hmm.
I mean, terminal calculator is a pretty easy one. It's one that a lot of people recommend. Personally, I recommend trying to make a network service. Those are pretty easy. They can be pretty bare bones. They're pretty easy to test too.
Mm-hmm.
Just create a project, the kind that you would want to use in real life, and just look and see. Just kind of bump your head on that, and then look and see at how other projects do it.
Mm-hmm.
The best way to learn programming, and this is how I learn. I know everyone's different when it comes to this. The best way to learn programming, in my opinion, is to do it yourself and see what other people are doing.
Mm-hmm.
Because really, the best way of learning programming, I call myself self-taught, is look at what other people do and ask yourself, okay, what's good about this? What's bad about this? And how can I apply it to my own thing?
Mm-hmm.
Because ideally, you'd just be able to see what other people are doing, recognize what's good, what's bad, what needs to be different, and apply it to your own projects. Really, the best way to learn programming is by doing. You have to do programming in order to really get good at it.
Yeah, practice.
You can read a lot of books. You can read a lot of source code, and I do recommend doing that. Books and source code have very important information, but really, the only way you can become a good programmer, the only way you can become, create something approaching, and people have called me over enthusiastic for saying this art, is to really do programming.
Mm-hmm.
Write some source code down, create a working project, try to make it more elegant, try to refactor it, try to integrate it into other things.
Mm-hmm. Mm-hmm.
Some people make fun of me because I think that source code can genuinely be art, but there's really good source code out there. I've mentioned, and this is definitely an ego boost here. Smol has some really good source. I try to keep it in such a way that reading Smol is like reading a book, watching a good movie unfold.
Mm-hmm.
And maybe I'm just being very, very green here. I do think source code is fun to read.
Mm-hmm.
Some other good code bases to read. The Swash code base is a little bit cryptic, but I think it's kind of genius how everything's put together. Swash, that's the text rendering library.
Mm-hmm.
Anything by the Rust C source code too. It's dense, but it's very very good. It's very well commented. It's very well structured. Even a knucklehead like me who knows nothing about compilers can understand it.
Mm-hmm.
What else? Linux source code is generally pretty good. I'm not gonna call it great. There's a lot of different hands on that project, but overall, I'd say Linux source code is generally very high quality, generally very good to read. There's just a lot of it. It's very hard to know where to start.
Mm-hmm.
What else? Man, I can probably think of more if you gave me some time, but like those code can really be art. I guess to kind of bring it back around full circle. If you're a newcomer coming to Rust, the first thing you have to do is to really find art in source code.
Mm-hmm. Mm-hmm.
Because once you can identify what good source code looks like and what rules it follows and how it follows them, that's when you start being able to take it and go, okay, here's how I create my own.
Mm-hmm. Wow. Okay. That's also a good advice for me. So yeah, I'll start reading code source of smol-rs more. Thanks for I'm
Thank you.
joking. So yeah, actually, I think I don't have any more questions. Perhaps you have something to
I
ask me.
enjoyed this.
Yeah, I loved your talking to you is like taking a fresh breath of air, John. You're really passionate and things you're talking about
I
talking
try to be
about.
passionate about what I do.
Yeah, it's great. It's great.
Otherwise, what are you here for? I guess the questions I have for you, what brings you to Rust specifically? Like you've asked me, what brings me to Rust? What made you decide? Because you do DevOps, you said, but like, what made you decide? Okay, for fun, I'm going to program in Rust.
So in DevOps world, I think like most of the DevOps learn Python as a language to use.
Yeah,
And
it's good glue.
yeah, so like also Go, but Go is not used that often unless you work on
I'm
some
going to
really
be honest.
specific
I
things.
I, I kind of earlier said I don't really like Go. I don't really like Go. I've tried programming in it. It just doesn't mess with how my brain works.
Mm-hmm.
I understand its strengths. I understand that it's very widely used for a reason. I just don't like programming in it.
Mm-hmm. Gotcha. Yeah, to be honest, I also didn't try that much of Go. I worked with it for a little bit, but it was also not really my cup of tea. But mostly, yeah, it's Python. And I've disliked Python since my university days, to be honest. I just really don't
Really.
like this language. I mean, you told me it's your second favorite language, but I don't know, it's just
Yeah.
I hate working with it. And I
I can
always
definitely see that. With Python, there's 3 million ways of doing the right thing, and like 2 million of those are awful.
yeah, actually very true, very true. And I just wanted to challenge myself and use Rust, to be honest. And yeah, my project was kind enough to allow me to experiment and create like so we work with cloud, create some Lambda functions, and
Really.
yeah, yeah. And
That's
I
what got was that what attracted you to the Rust, the challenge?
yeah, to be honest, it was the challenge. And I just really enjoyed it, to be honest. And I also liked the community. I think everyone was really friendly and helpful. And I just thought I would stay doing Rust and learning more about it, you know?
It's fun, isn't it?
Yeah, for sure. I think it's challenging to me, but at the end it's really rewarding and I like that feeling that I feel good about myself. I mean, who doesn't like that feeling, to be
Yeah.
honest?
Yeah, a little bit of going over a tough hurdle there. I
Yeah.
do enjoy that feeling too.
Yeah, right? See? So yeah, actually like that's basically what really attracted me to Rust. It was the challenge to myself. So yeah, actually I think we're good with the time. And if you don't have any
I just have one
questions,
more thing to
yeah,
add.
of course.
I'd like to kind of just advertise for a little bit. Right now, I'm working on a Rust compiler written in C.
Mm-hmm.
Speaking of compilers,
Mm-hmm.
will definitely be the hardest thing I've written if I manage to finish it. I occasionally talk about it on my Mastodon feed at notgoal at hackyderm.io.
I'll put
So
everything in the description.
yeah, I'll write like a blog post once I have something worth writing about. So far, I only have the Lexer done.
Mm-hmm.
Still working on the parser, the full parser for the Rust language.
Mm-hmm.
Once I have that done, it'll be great.
I'll check it out as well.
Thank you.
And I hope people that are watching this will also check and see. And I'll link like all the links. Maybe you can also like send me some of the things that we mentioned if I don't manage to find it myself.
Oh, sure. Yeah. No problem.
So yeah, thanks a lot, John, for taking time once again. And I'll say goodbye to you. And I hope to talk to you again soon.
Thank you very much. Have a good rest of your day and stay frosty, everybody.
Goodbye. Bye bye.